What's up, guys? Yeah, so let's solving this problem. Now, this problem is very interesting because I just copy one solution, right? But it feels me that this solution is interesting. So I might need you to make a video and explain why this is true. Okay, so given an array, hope you guys subscribe to my channel. So given an array integer nums contains some plus one integers with each integer in the 1 to n inclusive. Yeah, this is 1 to n is really important, right? This is the key to solve this problem. There's one repeated number. Nums return a repeated number. So, and the problem is that you cannot solve without solving. You can solve this. You must solve this without modifying array and use the constant extra space. So for example, 1, 3, 4, 2, 2, 2, right? And sorry, 3 is the same. 1 and 1. Okay. The problem is that if you use so let's see some simple idea, right? So the simple case, the simple solution, if you just don't care about this, then it's very easy, right? You can just create a dictionary, and you map and you count, right? You first one count 1, and then 3 count 1, 4 count 1, 2 count 1, and you see 2 count 2. Okay, so the answer is 2, right? The problem is that now this method do not use additional do not modify the array, right? But use the on memory. Yeah, so this is not good. Okay, so let's see the answer. So answer is very weird. Answer say that you just collect the number of 0, and you just collect the first one and check whether the indices, the num 0 is the same as it. If it's the same, then sure you'll find answer, right? So if it's the same, then you return it. If it's not the same, then you exchange the position and the number, right? So then you keep doing this, then you always get an answer. This is very weird. So basically, then we just run this algorithm for the first one. So 1, 3, 4, 2, 2, right? So it's 0, 1, 2, 3, which is indexes. Okay, so the algorithm says that you first check 1 and the 3, right? Because num of 0 is 1 and the num of 1 is 3, right? So you change this. They are not the same, right? If they are the same, then you find answer. If they are not the same, right? So you can exchange this to be 1 and 3. Okay, and the 3 check with 3, right? So 3 is 2. You exchange this. Right, so now 2 check 2, right? 2 is not the same as 4, right? So you exchange this. Okay, so now the miracle happens. 4 is the same as 2, right? So then you exchange this. Now 2 is the same as 2, you find it. Okay, so this is just constant space, right? The problem is that why this is true. Okay, why this is true. Okay, I think if you see the solution explanation, I think it's not clear why this method is true. Okay, but let me just give the proof why this is true. Okay. So my claim is that this always work, right? The reason is that let's say this is our original array, right? And let's say the first guy is alpha. The first guy is alpha 1. Okay. Then let's see. So alpha 1. So this is indices. So alpha 1 will find alpha 1 space, right? Will match alpha. So there's a case that there's a case is alpha 1 match with alpha 1, right? And then you find answer. So suppose this is not a case, right? You find answer is alpha 2, right? So that means alpha 1 is not the same as alpha 2. Then you will put alpha 1 into alpha 1, right? You will exchange this. Okay, alpha 2. Okay, so now you will check alpha 2, right? So maybe alpha 2 is here. So if alpha 2 is alpha 2, alpha 2 match, the index is alpha 2 match with alpha 2, then you get an answer, right? But the problem is that, okay, so let's say suppose alpha 2 match with alpha 3, and you just exchange this, right? So you get something. And so you put alpha 2 into alpha 2, and it is alpha 3. Okay, so notice that why this iteration can always happen, because the answer we already know all the array fitting 1 to n. So any of these will match to something, right? So this is the basic. Okay, so now you see so now alpha 2 is now the same as alpha 3. Okay, so now here comes the trick that so now you can keep going, right? So but there is a case that maybe alpha 1 is the same as alpha 3. Okay, so now here's the trick. If alpha 3 is the same as alpha 1, then it will try to match with alpha 1. Then alpha 1 will the same as alpha 3. If alpha 1 is the same as alpha 3, then alpha 1 match with alpha 1 will match to alpha 1, right? So this alpha 1 will the same as alpha 1. So that means once you keep iterating, then each after you iterate, this alpha 2 will match alpha 2, alpha 1 will match to alpha 1, and if alpha 3 is not the same, then alpha 3 will match to alpha 3. So every time you finish a step, you finish this step, that number exchange will fit into its correct position. So basically, you will sort your answer. If indices start from here, then finally you will sort your answer into 1 to n. So that means this position becomes like the test, right? And this position becomes like a test. Suppose you get alpha 4. If alpha 4 is the same as alpha 3, then you will match it. If alpha 2 is the same as alpha 2, alpha 4 is the same as alpha 2, you will match it. If alpha 2 is the same as alpha 1, you will match it. So each step after you do this, all this will be something which will become fixed. You will not keep changing. You cannot change this, right? But you only have finite number, right? So each time you do, the possible space you change decrease by 1, right? So finally you will get an answer. You will find something which is the same as your answer. So this is the reason why this is true, right? Because each k will match to k. So now this k cannot be happen. So you can always so the number of moves you can do will keep decreasing. Right. So finally you will match the answer. Okay, so this is a very interesting problem. Yeah, I mean, yeah, that's it. See you guys next videos.